Hello, this is my revision to COL QE1. Um, so for this quiz, we were tasked to draw up the sketch phase planes for two different situations. The first being y equals x with corresponding e to negative t, and y equals negative x with corresponding et. So the first thing that we would do is draw our y-x graph. And then we will draw the two different y equations that was given, which is y equals x and y equals negative x. So y equals x, y equals negative x, and I'll label that. So from here, in order to determine if our graph will be going towards the origin or towards infinity or just away from the origin, will be to look at the corresponding sign in front of the our t's for our e's, and because our t right here is negative for y equals x, it will be going towards the origin because a negative exponent will mean it's going towards the origin. So I can do that for both sides on y equals x. And if y equals negative x, because the exponent is positive, it's going away from the origin, which I will label as so. Sorry for it being kind of scrambled. And from here, we will just look at the behaviors that will happen at each section of the graph. So anything right here will be going towards the origin, then away, as so. Kind of the same principles apply to each section. Just follow the arrows. Sorry. And this one the same as so. And just follow each direction that it goes. Now, for number 2, it is very similar to the graph above. Same principles. Do your y-x graph, the same lines, y equals x, y equals negative 2x. I will draw those out like so. The only difference is for this graph, both of the exponents are negative, and also this negative 2 will come into play eventually. So at first I will graph the y equals x. Again, pretty similar to what it is above here. It will go towards the origin, again, because it is negative. That's that line. Now, the difference between a negative 2 and a negative 1 in front of the t is that a negative 2 will produce a stronger pull towards the origin compared to a negative 1 or anything lower than that. So the higher the exponent, the higher the coefficient, the higher the pull. And that will affect the long-term behavior of each section of the graph. So at every section of this graph, it will pull towards the origin, just that in some places it will pull harder because of this negative 2. So for here, it will come down really hard, and then it will kind of cut in front of this, and then it will start to bring it down towards the origin like so. Kind of the same principle here. It will shoot really sharply, and then it will curve down as so. Same here. Shoot really sharply there. Then it will cut towards the origin like so. Kind of make my origin a little more prevalent. And same here as well. Shoot down really sharply and cut to the origin. And there you have COL QE1 revision. Thank you.